So in 6.1, we're going to investigate geometric shapes and figures. This is just going to be a little bit of an introduction and to get our minds thinking. Okay, so when we look at geometry in real life, a lot of things in our community, whether it be art or architecture, they use the golden ratio to build it or to construct it. Okay, and the golden ratio is the ratio of two lengths being approximately 1.618 to 1. And let me see. Okay, so the golden rectangle, when we use this in rectangles, this is when a rectangle is drawn according to the golden ratio. And what this does is this ratio makes rectangles more pleasing to the eye. Okay, so it's more attractive. Where we can see this in like everyday life is we can see this in art. Leonardo da Vinci, his Last Supper painting is to the right, and he used the golden ratio in the dimensions of his room and the table and the ornamental shields. Okay, and you can see them outlined in different color boxes there. And some more art that we see is Michelangelo, and he used the golden ratio in his painting of the creation of Adam. The creation of Adam is just one of the paintings on the ceiling of the Sistine Chapel. So there's like, it's kind of more of like a collage, and there's different paintings, and they all coincide, and they all tell a story, right? And the dimensions of this section of the painting use the golden ratio, as well as the section of the painting with Adam and God. You can see where Adam and God reach out their hand, okay, in the boxes that are constructed there. So now, let's use the golden ratio in architecture. So here's an example at the bottom of one of the pyramids in Giza, and it has a base of 230.363 meters and a height of 146.515 meters as well. Okay, let's show that the ratio of the slant height is half of the base half of the base follows the golden ratio. Okay, so let's show that. So what we're going to do is we're actually going to just use one of these triangles, and we're going to find a slant. And we know from grade 9, a long time ago, that the slant height is this right here. So let's actually divide the base into two. So let's go 230.363, and we're going to divide that into 2. Okay, so 230.363, and let's divide that into 115.1815. Okay, 115.1815. Okay, and that's going to be right here, this section, 115.1815. Now, let's use Pythagorean's theorem to find the slant height. So let's do actually, let's write out the formula just as a review. Okay, a squared plus b squared equals c squared. So we'll do 146.515, square that, plus 115.1815, we'll square that, and then we'll solve for that. Okay, so I'm going to put both of those into my calculator together. Okay, 146.515, I'm going to square that, plus 115.1815, square that. I get 34,733. And I'm going to leave, I'm not going to write all the numbers out here, but what I'm going to do is I'm going to leave this on my calculator. 34,733.42, and so on. And we're going to root that in order to find C. Okay? So, leaving that on my calculator, I get 186. Let's round up to 37. Okay, so I get a slant height being 186.37. Now, let's take this 115, this is another color, 115.1815. Let's multiply that by the golden ratio, which is 1.618. Let's see what we get. 115.1815 times 1.618. And we get 186.36. So as we can see, our between the base, so half of the base, and the slant is the golden ratio. Now let's talk about tessellation. So this is a pattern that covers a plane without overlapping or leaving gaps. Okay, it's known as tiling. So if you take a look at the girl's shirt right here, this is an example of tessellation. Okay, we see a zigzag pattern here. Okay, and here are some of the generally accepted principles. 4 colors are usually used in order to be pleasing to the eye. Okay, triangles are commonly used, but all geometric figures can be used. And what we do is we start with a rectangle as just shown below, and we cut out a shape from the bottom. We basically paste it on the top in order for it to be like a perfect puzzle piece. Okay, and then in this way, the pattern is always going to fit and have no gaps. Okay, so let's create a tessellation. You can create your own, but if you just want to follow mine. So let's go up in a triangle, and then this part here, what we're going to do is we're going to do the exact same piece at the top. So this will be zigzag. And then if you want to do a circle down, half a circle, semicircle, we can do that. Because then this piece here is going to fit into this piece. So this shaded in is not part of the pattern. Our pattern is just going to be in the middle. Okay, and then we can go, it doesn't matter. We can do a little worm, 1, 2, 3, 4. So we'll go up, 1, 2, 3, 4. Okay, and then we can do a V down, and then maybe just straight. And that could be a pattern. And every single time we duplicate this and we paste it on top, it's going to fit with no gaps. As long as we cut out the shapes exactly the same. All right, and here's just a couple did you knows. So a little bit of an appreciation for geometry. So sewers are round. You can take a look right here, we know that sewers are round. The reason why we use round sewers is so that they don't slip into like the smaller opening. Okay, while doing maintenance. Okay, diamonds in real life, diamonds must be cut at certain angles in order for the light to shine and to optimize that shine. And when they're cut at certain angles, and they're going to be worth more. Okay, so $sign. Okay, we know right triangles. So right triangle is just a triangle with a right angle right here. And obviously like squares, rectangles are used, so these right angles, these are used in construction very often because this is going to be the strongest support for a wall. Okay, if we make a wall like this and we put weight here, what's going to happen is it's probably going to tumble down. Okay, so this right angle is the strongest support. And one last one in our community, the Pantheon in Rome. This has like a circle opening, and if you can see this light shine in here, what it acts like is a natural sundial. So it's pretty interesting. So we can see geometry so much in our everyday lives, and even like the construction architecture from the past.